Hello everyone and welcome to Precalculus. Today we're going to be doing a continuation of the law of sines in 6.1. And if we were in school, then these first 3 word problems I actually wouldn't even teach you. I would just set you guys off in your groups and let you do them on your own. So here's the 3 answers, and maybe you'd like to just try them on your own. But of course I will do them for you in case you can't get one of them. So the first one says a pole tilts towards the sun at an 8-degree angle from the vertical. So from the vertical means 90 degrees. So this is what a pole is supposed to be doing. Apparently this pole is tilting a little bit. Kind of hard to draw exactly 8 degrees, but it's a very small tilt. And it casts a 22-foot shadow. Now, believe it or not, the biggest problem people have with this problem is drawing it. If the sun is up here, then its shadow is going to be going this way. And it says that this shadow is 22 feet. The angle of elevation from the top of the shadow to the top of the pole is 43 degrees. How tall is the pole? So before we learned the law of sines, we were only able to solve problems that involved a right triangle. But this one is not right because the pole is leaning. So it's 90 plus 8. This is 98 degrees. So the key in every law of sines is always about having a matched pair, meaning as long as you have an angle and a side, you can use the law of sines. So I looked for a matched pair, and I realized this is a little confusing up here because I put that 8 degrees, but that goes with this one. So this 98 is across from this side. I don't know that. This 43 is across from the pole, so I don't know that. And this 22 is across from another angle that I don't know. But remember, the sum of the angles in a triangle is 180. So 180 is 98 plus 43 plus that missing angle. And since that one is the one that matches the only side I know, I do need to find it. So let's just call it B. 180 minus 98 minus 43 is 39. Okay, so remember the key is having a matched pair. So 22 feet is to sine of 39. And then I try and get my other matched pair. I'm looking for the length of the pole, and this is 43. So X is the length of the pole, and sine of 43. You can clear this sine of 43 by multiplying both sides by sine of 43. And you will get X is equal to 23.84 feet. Number 2, point A, the angle of elevation to the top of the tree is 38 degrees. From a point B, 25 feet closer to the tree, the angle of elevation to the top is 48 degrees. How far is it from point B to T, the top of the tree? And how tall is the tree? So here's my tree. And here's my point A. And from point A to the top of the tree, the angle of elevation is 38 degrees. Point B is 25 feet closer to the tree. So here's my B. So now it should be steeper. Let's see what it is. Yep, the angle of elevation is 48. So this is 48. How far is it from B to the top of the tree? So you may remember from last chapter that we had to make a right triangle, and then we had to figure out something for this right triangle so we could do the bigger right triangle. It's a lot of work. But now that we have the law of sines, we don't have to have a right triangle. We just have to have a matched pair. So when I look at that, I see that 38 is going to be with my X. So let's say X is to sine of 38. And then the question is there any other point that I know? Well, I didn't fill it in the picture yet, but it says that point B is 25 feet away. So if this is 25 feet, it would correspond to this angle up here. So 25 is to sine of, how do I get that angle? Back to the same way we did it last time. You have 3 angles in a triangle. So minus 38 and then minus this one. Now to get that one, 48 plus the black angle is 180 degrees because they are supplementary. So 180 minus 48 gives me 132. I'll have to squeeze in this little picture. So now 180 minus this 38 minus this 132, that'll give me the measure of that little red angle up there. Minus 132 is 10. Oh, it's tiny, which makes sense. It looks tiny. Is sine of 10. So now you can go ahead and clear this sine of 38 by multiplying both sides by sine of 38. And you get x is equal to 88.64, but you'll notice that the directions said express your answers to the nearest foot. So 89 feet. The second thing that they want to know is how tall is the tree. So we'll call that y. So now you have some choices. Remember, you don't always have to use law of sines. In this triangle, you just found x to be 89, and you know that this is 48, and you're trying to find y. This is a right triangle because you're trying to find how tall the tree is. We're assuming the tree is standing straight upright. So what trig function do you know that connects opposite and hypotenuse? Sine, not the law of sines, just basic sine. So sine of 48 is equal to opposite over hypotenuse. So you can go ahead and do that. Sine of 48 and times 89 is 66 feet. There you go. You can either write out the word feet or use that little abbreviation. Number 3, a space shuttle pilot who is flying toward the Suez Canal, might be thinking, aren't space shuttle pilots out in space? But they do come back to Earth. So when they come back, they are flying. So let's say your Suez Canal is here. When he's flying towards it, he has an angle of depression. Remember, a lot of people really struggle with this. Angle of depression means that this is his normal line of sight. Angle of depression is going to be when he looks down. So his angle of depression, I think I'm going to have to re-extend my Suez Canal. He can see both the near end of the canal and the far end of the canal, which is going to give him 2 angles. So we have the big angle, which is 52.75, and the little angle, which is 38.25. And it says that the canal is 100.6 miles long. So I don't know if you can picture this, but as he's flying, here's the canal, and he sees the near end of it. If he looks really far down, if his angle of depression is 52, but if he's looking way over at the other end, which is 100 miles further out, he only has to look down 38.25 degrees. All right, so again, if this had been last chapter, you would have had to make a right triangle and do a lot of extra steps. But in this case, you're gonna use, we still want to know that x, but you can find things in this triangle even though it's not a right triangle by using the law of sines. So what would be most helpful to me? Well, I would say this is, I'll call that W, because then that would be part of this bigger triangle. Let's label some more angles. Based on if 2 parallel lines are cut by a transversal, alternate interior angles are the same, That means that if this is 52, this is also 52. Remember, alternate interior angles when two parallel lines are cut by a transversal are congruent. So see if you can figure out on your own which other angle is 38.25. So here's his horizon, so to speak, and then here's the ground. So this is the thing that is considered the transversal. So this angle is 38.25. Okay, so now that I've used all my angles, do I have anything that matches? Not yet, because this 100 is the only side that I know. So I really need this teeny tiny angle right there. So I have a couple different ways to find it, but the fastest is 52.75 minus 38.25. So this little angle is 14.5. All right, now that I have that, I have a matched pair. That's always what you're looking for, so I can use my law of sines. 100.6 is to sine of 14.5. And what is that going to? What do I really want to know? I want to know W. I really want to know X, but it's not part of my triangle. I want to know W, and that one is across from the 38. So I'm not even using that 52. So W is across from the 38, sine of 38.25. So I multiply both sides by sine of 38.25 times 100.6 divided by sine of 14.5, and I get 248.745. So that's this right here. 248.745. Now can you see how to find x? Hopefully you're doing it on your own, but this is a right triangle because altitude is straight up, and now I can just use a regular trig function. Same as last time. Sine of 52.75 is opposite over hypotenuse, 248.745. Now this number is actually still in my calculator, so when I multiply it to both sides, I'm just going to write 248, but I'm actually just going to, on my calculator, just hit times sine of 52.75, and it's just going to give me the answer right away. X is equal to 198.00176. Let's see, did they ask us to round it any certain way? Nope. So about 198 miles. Remember, it's a space shuttle, so it's way up high. So another application of the law of sines is using it to find area of a triangle. So hopefully you remember that the area of a triangle is 1/2 base times height. So on this one, we're almost there. We have the base, we just need the height. Can you find the height? You sure can. You can use trig. So which trig function would give you this? Now remember, you have this 8, but that's the whole length. So if you're just looking at trying to find h in this right triangle, you need to use the 4 instead. So sine of 49 is equal to opposite over hypotenuse. So sine of 49 times 4, the height is sine of 49 times 4, is 3.0188. And that gives us an area of 12.08 centimeters squared. So I want to back up for a minute, and I want to show you that what we did to get this number, right? I multiplied both sides by 4, and that gave me h. So another way that I could say h is h is one of these sides times the angle that's next to it, which is not the greatest way of writing it. So somebody came up with a formula and said, instead of stopping and doing the trig to figure that out, let's put the trig right into the formula. So in addition to this formula, I'm going to give you a new one. For some reason, they use the letter K instead of A. I don't really know why, but that's just their thing. So the new formula is that K is equal to 1/2 BC sine A. So what they did to account for this, which side, which angle, is they're saying if you do 1/2 the base, so let's call this base, and then this is side C, that would make this side A. So the angle that you want to talk about is angle A. So this part represents the height, because height is, we just figured it out, right? C times sine of A. C times sine of A. Do you really need to know that explanation? Nope. All you need to know is that this is the formula. But even more importantly, you might not have it be written in that format. You could say K is equal to 1/2 AB sine C. So don't let the letters get in your way. Any combination will work. 1/2, what's the last one? AC sine B. So no matter which way you do it, it's going to work. All right, let's put that into a problem now. So I have C is equal to 57. Let's make that C. A, doesn't really matter which one you make A. A is 31. B is 42. So if you don't write this formula down in your appendix, or if you don't memorize it, is it still possible to do this problem? Yeah, we just did it a minute ago. 1/2 base times height. You could find the height using trig, and you could always do that. But this formula is giving you a little bit of a shortcut. This is saying that if you know two sides, B and C, and the included angle, so 42, 31, and then sine of 57, you can just use that formula. So it's an awesome shortcut. It's a little not useful because people don't generally have this formula memorized, but most people have this one memorized. But if you're about to do 10 homework problems, this formula is awesome. All right, so you multiply that out and you get K is equal to 546 square centimeters. Now, your book does a funny thing. They ask you for it to the nearest 10 square centimeters. So they want a multiple of 10. So 10, 20, 30, 40, 50, or in this case, 550 square centimeters. I think they're just letting you practice different kinds of rounding. Usually it's to the nearest number or to the nearest tenth, but to the nearest 10, so something new to try. All right, we can use that for this. We have an area for a rectangular lot having two sides of length 90 and 52 and an included angle. This is the key, because it doesn't matter how you label them. A, B, C, then this would be side C, this would be side A, and this would be side B. Our formula specifically says, okay, this time I want to use C. So 1/2 AB sine C. As long as you have the angle that's not the same as the two lengths, that's the configuration of the formula you want. So that would give us K is equal to 1/2 times 52 times 90 times sine of 102. And that would give me 2,288.87. What is our meters? Square meters. It doesn't say anything about how to round, so you can just leave your answer just like that. Number 3, given A is equal to 61, B is equal, I'm going to put A over here. We never do that. Let's put it someplace new. A is 61, B is 78, and C, side C, it's a lowercase, is 37 inches. So I don't have what I need this time. Remember that K is equal to 1/2 some combination, AB sine C or BC sine A. So the question is what to do now. You still need to find one more side. Well, you can use the law of sines for that. So in order to use the law of sines, I do need a matched pair. So of course, I'm going to do 180 minus 78 minus 61 to get this angle of 41. 180 minus 78 minus 61. That's how you get that. Now that I have a matched pair, 37 is to sine of 41 and it doesn't matter to me which one you find. So let's find B. B is to sine of 78. So I have 37 times sine of 78 divided by sine of 41, and I get B is equal to 55.165. Now I can use my formula. 1/2. All right, now I'm not choosing this one. If I found B, I actually need 1/2. I'm going to use angle A because I have B and C. BC sine A. So B, 55.165. C, 37. Sine of 61. And when you do that, you're going to get K is equal to 892.51. Although, again, always read the directions. This one wants it to the nearest 10 again. So that would be 890 square inches. So somebody thought about this and said, well, let's see if we can make yet another formula. So this one's good, but only if you have side, angle, side. You have to have it be inclusive like that. This one gave us angle, angle, side. So of course, since we were able to figure it out and then put it in, somebody said, let's just put that in the formula. And this is what they came up with. K is equal to C squared, sine of A, sine of B, all over 2 sine C. So now that we have that, can we redo question 3? Absolutely. So now K is equal to C, which was 37, that's what we were given, 37 squared, sine of A, 61, which we were given, sine of B, 78, which we were given, and we actually weren't given angle C, but remember, we were able to find that pretty easily. So 2 sine of 41, and you'll still get the same answer of 892.51, which again, we rounded to 890. So is it a great shortcut? Sure. But the only way it's helpful to you is if you have all these formulas written on your appendix and you know when to use them. This one's great if you just know one side. If you know one side, and I'm going to say 2 angles because you really need all 3 angles, but if you know 2 angles in a triangle, you can find the third one. All right, with that is the end of section 6.1. You have a great day.